Yo, let's talk about inverses while I spit some verses. Curses, Feltham's doing it again. All right, sorry about that. I'm really excited about this 3-day weekend, really pumped. But anyways, here's your lesson over inverses. And so by the end of today's video, you guys should be able to solve for the inverses of any n by n matrix using multiple methods. So this 3x3 right here, we're going to be solving here in a second. But before we do that, let's go ahead and review how to find the inverse of a 2x2 matrix. So here, let's call this matrix A. And so we already solved one 2x2 inverse last class, but let's go ahead and just do this one for extra practice. So here we're saying that A inverse is equal to 1 over the determinant of A times that funky matrix. And here's our A, B, C, and D. So let's go ahead and fill in that matrix. 4, 2, negatives by our B's and C's, and our A's and B's are flipped. Okay, but what's the determinant of this matrix A? So the determinant is equal to 1 times 4 minus 2 times 3, which will just give us -2. Okay, so we can rewrite this as being 1 over -1/2 times 4. All right, so now let's go ahead and multiply that -1/2 in. We'll get that our inverse is equal to -2. Okay, so here's our inverse. Now, if we were to take A, our original matrix, times our inverse right here, we should get the identity, or a matrix with zeros in the diagonal. Okay, but now let's talk about this 3x3 matrix. How can we find the inverse of this? So in that last slide, I was talking about A times A inverse is equal to identity. Well, let's use this identity to help us solve for A inverse. And so what we're going to do is augment this matrix here, A, with the identity. And what I mean by that is, let's go ahead and write our matrix down. By augmenting it, we're drawing that line that we're so used to and having it augmented with the identity. Now, why do we do that? So anyways, what our goal here is to RREF, which I'll go over here in a second, to make this side look like the identity using our row operations, and make this side look like A inverse. Now RREF, that's a step further than REF. Now REF, you should all know fairly well by now, is equal to, if we're looking at a 3x3 matrix, this matrix right here. But if we RREF a matrix, it's taken a step further, and instead of having zeros underneath it, we're also going to have zeros above our ones or our diagonal. Okay, so let's go ahead and RREF this left side, or the whole matrix. So to start, I would say, okay, let's REF it first, try to get zeros beneath all of our ones in our diagonal. So first, let's get zeros in our first column. So we already got the 1, which is great, so let's subtract 2 for first row. Okay, when we do that, we'll get first column stays the same, or the first row stays the same. Okay, and we'll get 0, 1, 1. Now we're subtracting 2 on this right side too. So we're subtracting 2 of that first row. So end up getting -2 here, 1, 0, and this is all going to stay the same. Okay, so we got zeros underneath our diagonal. We just need to turn that 2 into a 1. So let's multiply by 1/2. I'm going to pause the video and finish this matrix 2/3 of the way done. Okay, so we multiplied that bottom row by 1/2. So these zeros stay zeros. It's 2 constant of 1. Zeros stay zeros. But this 1's going to turn into a 1/2. Okay. So now what we need to do is turn these guys right here into zeros to get into this REF form. Okay, so I'm thinking let's just subtract the second row from the first one. When we do that, what will we get? So we'll have 1, 0, 0, because we're subtracting those ones. Now we're going to do -2, or 1 minus -2. So we'll get a 3 right here. And we get a -1, 0, and the rest stays the same. Okay, so the last thing we have to do, turn this guy into a 0. So let's just go ahead and subtract row 3. Okay, I'm going to pause the video and unpause it with the solution. All right, so here's our final solution. And we've done what we wanted to do, right? Because we wanted the left side to look like the identity. When we do that, our right side should be the inverse. And so since the left side's the identity, this guy right here should equal our inverse. Now if you wanted to check that, you do A times A inverse, and you should get the identity. Okay, but now I want to show you guys how to do this on your calculator. Okay, so let's look at that same matrix, and we'll call this A again. Let's go ahead and open up our calculators, and let's solve for the inverse of A. So to do it on a calculator, go to your matrix options, go to edit, and let's edit A. So we're looking at a 3x3 matrix here. Now let's enter in all of our variables, or all of our values. And by the way, while I'm doing this, I want you guys to have your calculators out and doing this with me. So we should all have this 3x3 matrix in our calculators. Okay, so second quit out of this. I'll go back to second matrix, A. Now you guys are going to believe how easy this is. So remember that inverses are represented by this -1 right here, right? Check this out. Press that X to the -1 button. Boom. There's your inverse. So if we want to check our work here, let's go back to where we've solved for this inverse, go to our calculator, and be like, oh man, that's awesome. I did it right. Way to go, self. Which you guys should totally feel like right now because you guys have done such a great job. Okay, so those are the 3 ways to solve for an inverse by some n by n matrix. Now all you guys have left to do is watch the partial fraction decomposition. I'm actually sorry, we're not going to do this. We're actually talking about solving systems of inequalities. Okay, so watch that second video, and I'll see you guys at the end of the weekend.